So moving forward, let's take up question number 4. The trace of a square matrix is defined to be sum of its diagonal entries. This is known to us. If A is 2 by 2 matrix such that the trace of A is 3. Is this clear? Alright. The trace of a cube, a bit calculative, is minus 18, then the value of determinant of A is. Let's understand what the question is talking about. Now, it is given to me, say for example, if I consider matrix A as X, Y, Z, W. Since the trace of A is 3, if I take this term as W, so X plus W will be 3. So instead of W, let's write 3 minus X in order to eliminate one variable. This is clear? Question is asking for determinant of A. So what that would be? This will be 3x minus x square minus yz. This is what we have to find. Correct? Now moving forward, let's find out first A square. This is x, y, z, 3 minus x. Since 3 unknowns are involved, the question has just one more constraint, that is trace of a cube is minus 18. Chances are very high when you would be finding a cube and its trace, you would be getting this result directly from there. So let's work in order to find first A square, and then possibly after getting A cube we will get the result. Alright, so multiplying we have x square plus yz, then xy multiplied with 3y minus xy, that is finally 3y. Here you have xz and then minus xz plus 3z, that is 3z only, and the last element comes as simply yz plus 3 minus x whole square, that is 9 minus 6x plus x square. So this is A square. Getting complicated as I said in the beginning. Now moving forward to find A cube. What we need to multiply this term again with A. So let's write down this term, x square plus yz, 3y, 3z, yz plus 9 minus 6x plus x square. Now we need to write A as well, that is x, y, z, 3 minus x. Now what the question is asking for, trace of A is minus 18. It is given since trace A cube is minus 18. So this is given to me, trace of A cube is minus 18. Trace of A cube meaning you need to multiply first row with first column, then second row with second column. That will give you the diagonal elements. So no need to simplify completely. Let's move ahead. When you multiply this row with the first column, we are getting x cube plus xyz plus next this 3yz. Correct? So what we have done, we multiplied this row with this column. Next second row to second column plus 3yz plus last term required this element to this one, meaning 3yz plus 27 minus 18x plus 3x square minus xyz minus 9x plus 6x square minus x cube. This is given to me minus 18. Let's see after simplification what we are getting here. We can see that x cube cancelled, xyz cancelled. We are left with 3 plus 3 plus 3, 9yz. Next, we have taken these three terms so far, 27 and 18 added, that is plus 45. Correct? I have taken this term and this one. Minus 18x minus 9x, that is minus 27x is there. Then 3x square plus 6x square, that is plus 9x square. This is 0. Or I can say yz minus 3x plus x square, this is minus 5. Now let's check out what is required. We are looking for 3x minus x square minus yz. This implies that 3x minus yz minus x square is 5. So what is the required result over here? Yes, the required answer is simply 5. A bit lengthy, you can see that it was calculative one. Moving on to the next question now, that is question number 5. Let f and g be defined as fx is given mod of 2x minus 1 plus mod of 2x plus 1, while gx is x minus greatest integer x, or simply you can say fractional part of x. Now what the question is talking about, let f of g minus 1 to 1 to r be the composite function defined by, simply we know that this is f of gx. Suppose c is the number of points in the interval minus 1 to 1 at which FOG is not continuous, and D, this is the number of points where it is not differentiable. Correct? So we have to find value C plus D. So we have to find the points of discontinuity and points of non-differentiability, total number of such points. Let's write down the function. We can see that function fx is given to me as mod 2x minus 1 plus mod 2x plus 1, while function gx is given to me fractional part of x. Moving forward, we can say f of gx is equal to mod 2 fractional x minus 1 plus mod 2 fractional x plus 1. Right? Clearly we can see that we need to break it around 0. Let's try. This is equal to, when you say x is less than 0, correct? What will be fractional part of x, which is x minus greatest integer x. So you have 2 times x plus 1 minus 1, its modulus, plus 2 times x plus 1 plus 1, its modulus. This is the case when x is less than 0. And when you say x is greater than 0 or equal to 0, in each case you can include here, that gives you twice x minus 1, its modulus, plus 2 times x plus 1, its modulus. This is the case when x is greater than or equal to 0. Now, here I can see that points of discontinuity. Clearly, when you move around 0, left hand limit, what you obtain from here, you are getting simply 2 minus 1, its modulus, that is 1, plus 3, that is 4. This is the left hand limit around 0. Right hand limit, this is 1 plus 1, that is 2. So clearly it is discontinuous at 0. Points of discontinuity, 1 is x is equal to 0. When you talk about half and minus half, due to modulus function, it's not going to give any change because modulus is continuous at the points where it is changing its nature. Simply the difference is it has a straight line inside term, so it will give you V-shaped curve. This is all, but discontinuity will not come. So just 1 point of discontinuity, x equals 0, is obtained. Now, non-differentiability, we can see, so x equals 0. Now, point of non-differentiability, next one. It looks like half and minus half may be a possibility, but when you look at the interval x is greater than 0, so obviously this is going to make the difference. At this point, either less than minus half or greater than minus half, it is not going to give any difference. So yes, it will give you x equals half. Next, from this interval you can see that this gives you minus half. From here you have 2x plus 3, that is minus 3 by 2 is not there in this interval. So yes, minus 1 by 2 is also point of non-differentiability. So 3 points of non-differentiability and 1 point of discontinuity. So total number of points, that is C plus D, we obtain it is 4. I'm sure this question is also clear. Let's take up the next question now. This was question number 5. Time to move on to question number 6. So taking up the next one, question number 6. The value of this limit, a big function is given. Let's try how we can start it. In numerator, we have sin C plus sin D type term. In denominator, we have 2 sin A sin B type term or cos C minus cos D type term. Any of the two results can be applied to denominator. In numerator, obviously, we have to apply sin C plus sin D. For denominator, we can plan cos C minus cos D or 2 sin A sin B expansion, any of the two things. Let's say once you plan for 2 sin A sin B expansion, you will be getting 4 terms of cosine. 2 were already there, 2 will also be obtained. Then rearrange and try to take terms in such a fashion that something can come out, or directly go with cos C minus cos D. So starting it, we have 8 root 2. This gives you sine 2x into cos x divided by, in denominator you have, under the limit obviously, x approaching to pi by 2. Denominator you have 2 sine 2x into sine 3x by 2 plus, applying cos C minus cos D, this gives you 2 sine C plus D by 2. So you have 8 by 2, that is 4x, upon 2, that is 2x. This is multiplied with sine minus C plus D by 2, that is 3x minus 5x, 2x upon 2, simply minus x, upon 2. So you have multiplied with sine minus x by 2. Next, you have minus root 2 times 1 plus cos 2x, that is minus 2 root 2 cos square x. So this is all you have in denominator. Just focus so that you can get the correct result over here. All right. Moving forward, we can check what can be cancelled. X is approaching to pi by 2, that is cos x is a problem figure. We have to eliminate cos x as much possible. This will be expanded, so another cos x will be obtained. So 2 cos x terms are there in numerator. We need 2 from denominator in order to cancel. When you expand it, this is 16 root 2 sin x into cos square x divided by, in denominator you can see that 2 sin 2x taken common. Inside bracket you are left with sin 3x by 2 minus sin x by 2. So sin C minus sin D can be applied. That gives you 2 cos C plus D by 2, that is 3 plus 1 by 2 by 2, right? So we have 4x by 4, that is simply x. Next, sin C minus D by 2, C minus D by 2, that is 3x by 2 minus x by 2 upon 2. This is clear? So this is into sin x by 2. This is the term we are left with these two, minus 2 root 2 cos square x already there. So this is what we have as the figure in denominator. Moving forward, limit x approaching to pi by 2. Let's see if something can be cancelled. This is 1 cos x. When you expand it, 2 sin x cos x, so cos square x will be there as the first term. Here again you have cos square x, cancel it, right? Next, we have 2 here into 2, that is 4. When expanded, another 2, so 8, right? Let's write down so that there would be no error. 16 root 2 sin x divided by, denominator has this one, cos square x is cancelled, 2 into 2 into 2, that is 8 sin x by 2 minus 2 root 2. I think we can apply limit because there is no problem figure is left. Yes, we can go for it. On applying limit, you have 16 root 2 divided by 8 upon root 2, that is 4 root 2 minus 2 root 2, giving you simply 2 root 2 or the final result as 8. So I'm sure this part is clear, that how we are getting the solution for this question as 8. So this was a question from limit, right? Let's take up the next one, question number 7.